Right now I am in Yellowstone National Park, or just outside of it. I have spent 1 to 2 months every winter here since I started school at Oregon State, setting remote cameras to monitor their cougar densities and abundance. And all my work involves carnivore interactions and population dynamics in Yellowstone National Park. We do captures and we fit them with GPS collars, and that leads to a lot of our predation work that we do. We can monitor them that way because we know where they are, looking at how they interact with other species. Cougars are very efficient predators, and something that they're quite good at is taking down prey that's much larger than themselves. These large prey species that are 4 or 5 times the size of an individual adult cougar. Especially here in this video, we have a bull elk that dropped its antlers, so they do that every spring. Perhaps that's a little bit less dangerous for a cougar to go after at that point because they don't have these large antlers that are dangerous for a predator trying to take them down. That provides a good meal for them, but it also means that there's a lot of other animals that would be interested in sharing that meal with them. So when cougars make a kill, they put all this effort in trying to hide that kill from other scavengers on the landscape. And for many species, it doesn't really matter. If the cougar's still there, they're not going to go mess with that carcass because a cougar's protecting it. But there are a handful of species on the landscape who can push a cougar off that kill. Black bears, so long as they're adults, grizzly bears, and wolves, because they're in packs, can push a cougar off a kill and steal that meal from them. So in this video, we can see 2 cougars that are alerted to something coming into this carcass site, and they're acting pretty skittish, and they eventually run off. And if you look in the bottom right of this video, you'll see a timestamp, and 15 minutes later, we have the wolf pack showing up and feeding on that carcass already. So when one carnivore steals a kill from another carnivore, this is a behavior that's called Kleptoparasitism. So it's theft, and it only benefits one species. But what's interesting about wolf and cougar interactions is that cougars are very proficient at hunting themselves. So they don't need to play this game of scavenging from other large carnivore kills because they can create those kill sites themselves. So it's intuitive to think that this might reduce their interactions with competitors like wolves, but wolves are very proficient at kleptoparasitism. Elk are the preferred prey of both wolves and cougars in northern Yellowstone, but over the last 30 years, their population has declined quite a bit. Cougars in particular have really increased their use of deer as elk numbers have declined. And what we are looking into is how that really affects the relationship between these predators who are competing over the same prey base. Because deer are smaller, cougars eat them faster. This gives wolves less time to find a cougar sitting on its kill. So kleptoparasitism rates are tied to the diets of cougars. So the whole dynamic of how they interact requires this different outlook, this different framework to describe what will affect their interactions. And that's what we were trying to do with our study here. With a lot of large mammals, people use various methods to catch them. For cougars, our options are somewhat limited because we're in a national park, so we can't set traps, we can't use foot snares, we can't use helicopters because it's not an efficient way to find cougars. So the capturing process is quite unique in that we use trained hound dogs that can follow the scent of a cougar, chase it up a tree, which gives researchers the time to catch up to that animal and then chemically immobilize it. We use ketamine, and only ketamine, to dart that cougar with because there's no sedative in that cocktail, so these cougars can still hang on to that tree but not really be aware of their surroundings, and that makes it safe for a tree climber to go up the tree, rope up the cougar, and safely lower it to the ground, where we can then do all the work that we need to, including fitting it with a GPS collar. The climbing itself is not actually that challenging. It's just that you're on the clock because you have this drugged cougar that you need to quickly get to rope up, and you hope that the drugs are also doing their job. What you try to get more in touch with is reading the behavior of that animal in the tree. Part of the motivation for this research is that wolves are actively recolonizing much of the American West. One thing that we were trying to look at with our work here was what's driving their interactions in a way that we might be able to predict how wolf-cougar interactions elsewhere might play out, which leads us to think that if there are these areas in the American West where cougars are currently inhabiting, if it's flat, open terrain, and they're primarily feeding on large prey such as elk or feral horses, these are the sort of areas where we might expect cougar populations to be sensitive to wolf recolonizations. If there's no escape terrain nearby, then cougars will run the risk of mortalities from wolves in those places.